Hello everyone. I welcome you to another mathematical fun discussion. Today's video is going to be about symmetric functions and how do we use them in polynomial problems. So first, let us learn what exactly a symmetric function. So let me explain through some examples. Say something like this, maybe something like this. So in these expressions, notice that if you change any two of these alpha, beta, and gamma, then the expression remains unchanged. Say you change alpha and beta, then what is going to happen? You'll get beta plus alpha plus gamma. And it's the same thing as the commutative property of addition holds. And here also, say you want to replace two of them, say you want to replace alpha and gamma, so you would get gamma plus beta times beta plus alpha times gamma plus alpha. It is the same thing if you notice. You would have to apply the commutative property of addition and also the associativity of multiplication. So that would give you that these two are the same expressions. So thing is, symmetric functions are those functions where you change any two of the n variables. Let us say there are n variables. You change any two of them, the expression would remain unchanged. So that is what is symmetric functions. So we would tackle this problem using symmetric functions. So let us just see what the problem is telling. It's saying that alpha, beta, and gamma are the roots of this equation, 2x cubed plus x squared plus x plus 1 equals 0. And we need to show that this expression, 1 by beta cube plus 1 by gamma cube minus 1 by alpha cube times 1 by gamma cube plus 1 by alpha cube minus 1 by beta cube times 1 by alpha cube plus 1 by beta cube minus 1 by gamma cube, that equals 16. So you notice that it's a very complicated expression because we have plus and then a minus and then product. Imagine how many terms you would get if you do it by brute force. That is just multiplying all the terms together. So, uh, how do you think we can start this problem? You can try to pause this video and think about it, and you may get the solution. And yeah, if you don't get, you can watch this video. So realize that this expression is complicated. So I can write this as 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube minus 2 by alpha cube. Why am I doing this? Because it's easy to calculate this expression where there are all pluses. That's the motivation. So yeah, this is the same thing again. We're going to do 1 by alpha cube plus 1 by beta cube. We're adding a beta cube, 1 by beta cube because it's a minus here, plus 1 by gamma cube minus 2 by beta cube. Then again, you would have similarly 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube, that minus 2 by gamma cube. So this is what we need to calculate. And what we're going to do is we're going to assume that this is some quantity, let us say k. This is k, this is k, and this is k, and we want to find k, right? So we need to find this expression, k minus 2 by alpha cube times k minus 2 by beta cube times k minus 2 by gamma cube. And this is not very hard to expand. It's simplified very much. So now our goal is to find out the value of k, that is 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube. How do we do that? That's where we need symmetric functions. So this is of course a symmetric function. You change any two of alpha and beta, you get the same expression. It's obvious. So the thing is, we need to first find the polynomial with roots 1 by alpha, 1 by beta, and 1 by gamma. First, we need to find that because then only we can use the idea of symmetric functions. So let us find this. So now let us calculate the sum of the roots. Sum of the roots is just 1 by alpha plus 1 by beta plus 1 by gamma. That equals alpha beta plus beta gamma plus gamma alpha by alpha beta gamma. So what is that? Okay. So let's go back and see. Alpha beta plus beta gamma plus gamma alpha. It's using vieta's relations. It's 1 by 2, right? And what about alpha beta gamma? Alpha beta gamma is going to be negative 1 by 2, right? So this is going to give you 1. Then we need to calculate this. 1 by alpha beta plus 1 by beta gamma plus 1 by gamma alpha. This is the, why am I doing this? Why am I calculating this? This is how we construct the polynomial with roots 1 by alpha, 1 by beta, and 1 by gamma. It's very much simplified using Vieta's relations. So that is what we are going to do. So this is going to give you, once you take the LCM, you'll get alpha plus beta plus gamma divided by alpha beta gamma. That's going to give you, we see what's alpha plus beta plus gamma, that is a negative 1 by 2, and again even alpha beta gamma is negative 1 by 2. That's going to give you 1. It is product of the roots. The product of the roots, that is 1 by alpha beta gamma, that is going to be, the product is negative 1 by 2, so this becomes minus 2. Now, so this is going to be our x square coefficient. So it's going to be something like this. We're going to have the polynomial to be x cube, a small mistake, 1 by alpha plus 1 by beta plus 1 by gamma is supposed to be negative 1. That's a small mistake. So yeah. So now it becomes x cube plus x square. A plus because when we use Vieta's relations, it's a minus b by a. And now this is just a 1 because it's c by a. Now negative of negative 2, that's plus 2 because it's minus d by a in Vieta's relations. So this is the polynomial with roots 1 by alpha, 1 by beta, and 1 by gamma. So let us call them as a, b, and c because it's harder to always write it as reciprocal. So since there are the roots of this equation, what can I write? A cube plus a square plus a plus 2 has to be equal to 0. That's the direct consequence of a being the root of it. Then b is the root of this, so we get b cube plus b square plus b plus 2 to be equal to 0. And similarly, even c is a root, so we get c cube plus c square plus c plus 2 to be equal to 0. So actually, what do we want? We want 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube. And you see that it's just a cube plus b cube plus c cube. So how do we get that now? How do we get it from these three equations? That's the trick. Add them up. So that's what symmetric function says. So we get a cube plus b cube plus c cube plus a square plus b square plus c square plus a plus b plus c plus 6, 2 times 3, that equals 0. A cube plus b cube plus c cube, that is our k. And we usually represent this as sigma of a cube. Sigma of a cube would imply that it's a cube plus b cube plus c cube. And we can write this as sigma a square and this is written as sigma A, and this is a plus 6 equals 0. So this is just the way of representing it, which will make it more quicker to apply it. You see this? You just write it as sigma A cube plus sigma A square plus sigma A plus 2 times 6 equals 0. You can directly see it from the equation. It's a direct step. But from where does it come? You write this down like this. The roots of the equation are A, B, and C. So we have A cube plus A square plus A plus 2 equals 0. B cube plus B square plus B plus 2 equals 0. C cube plus C square plus C plus 2 equals 0. And we add them up. So that's how we do the procedure. And once you get enough practice of this, you can write it directly. And yeah. So now I'm going to write this as just K because that's what we want to find. And this can be written as, we don't know much, A square plus B square plus C square. But we know an identity. What's that identity? So I'm going to use this identity. A plus B plus C the whole square is equal to A square plus B square plus C square plus 2 times of AB plus BC plus CA. This, of course, is a very nice relation which we are going to use. So again, we're going to use this. So I can write A square plus B square plus C square to be A plus B plus C the whole square minus 2 times AB plus BC plus CA plus A plus B plus C plus 6 equals 0. And now we are almost there. And what is A plus B plus C the whole square? That's 1 by alpha plus 1 by beta plus 1 by gamma the whole square. If you remember, we have already calculated what's 1 by alpha plus 1 by beta plus 1 by gamma. That's negative 1. So we have K plus negative 1 the whole square is 1 minus 2 times of AB plus BC plus CA. That was AB plus BC plus CA is this expression, if you realize. Since A is 1 by alpha, B is 1 by beta, and C is 1 by gamma, you could just substitute and check. So this is going to give us 1. So minus 2 times 1 plus A plus B plus C, that is negative 1, plus 6 equals 0, right? So then we have K plus 1 minus 2 minus 1 plus 6 equals 0, and we have a 1 minus 1 getting cancelled. We have K plus 4 equals 0, and we have K equals minus 4. Important, very important relation. So the sum of the cubes of the roots the sum of the cubes of 1 by alpha, 1 by beta, and 1 by gamma. That is 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube is actually negative 4. So now, a big leap. What was our expression? This, right? We found this out. And we know that K is minus 4 now. So let's put K as minus 4 in that expression. Yeah. So the expression was K minus 2 by alpha cube times K minus 2 by beta cube times K minus 2 by gamma cube. So, and K is minus 4. So minus 4 minus 2 by alpha cube times minus 4 minus 2 by beta cube times minus 4 minus 2 by gamma cube. So now we can pull minus 2 out from each of the product terms. So we are going to be left with 2 plus 1 by alpha cube times 2 plus 1 by beta cube times 2 plus 1 by gamma cube. Right. So this is going to give us minus 8 times, it's not very hard to expand this. We won't get, we would get 8 terms, that's all. So when we expand these two first, we get 4 plus 2 by beta cube plus 2 by alpha cube plus 1 by alpha cube beta cube. Then this multiplied by 2 plus 1 by gamma cube. So then we have a minus 8 times, so 4 times 2, that is 8, plus 4 by gamma cube, and 2 by beta cube times 2, so that's plus 4 by beta cube, and we get plus 2 by beta cube gamma cube. Then we get a plus 4 by alpha cube. Then we have plus 2 by alpha cube gamma cube, and a plus 2 by alpha cube beta cube, and then finally a plus 1 by alpha cube beta cube gamma cube. Wonderful, we've got this. So now what do we have? Minus 8 times 8 plus, let's group these terms. So 4 common, and what do we have? 1 by alpha cube plus 1 by beta cube plus 1 by gamma cube. And we know what this is. That's negative 4, the value of k, which we calculate. Then we have plus 2 times 1 by alpha cube beta cube plus 1 by beta cube gamma cube plus 1 by gamma cube alpha cube plus, what is 1 by alpha cube beta cube gamma cube? So realize that 1 by alpha beta gamma, what did we find out? That the value of 1 by alpha beta gamma is negative 2. So what would be 1 by alpha cube beta cube gamma cube? That would be negative 8. Wow, that's nice. And what's more nice is that this minus 8 and this 8 is cancelled. So now what do we have? So we have minus 8 times 4 times minus 4, that is minus 16, plus 2 times. So we can take the LCM here. You notice that you get alpha cube plus beta cube plus gamma cube divided by alpha cube, beta cube, gamma cube. And again, 1 by alpha beta gamma was negative 2. So 1 by alpha cube beta cube gamma cube would be negative 8. So we can write it as minus 8 times minus 16 plus, so 2 times minus 8 it would be, times alpha cube plus beta cube plus gamma cube. So, yeah. So what we have to find is that this expression, what is this expression? We haven't calculated it yet. So our next goal would be to calculate that. What is alpha cube plus beta cube plus gamma cube? Let's see what that is. And again, realize that alpha cube plus beta cube plus gamma cube is in fact a symmetric function. Because if you replace any two of alpha beta or beta gamma or gamma alpha, you would get the same expression. It doesn't change. So now alpha, beta, and gamma are the roots of this equation. The given equation, what was given in the problem? 2x cubed plus x squared plus x plus 1 equals 0. Two x cubed plus x squared plus x plus 1 equals 0. So now, let us see what we can do. So since alpha is a root, we have 2 alpha cube plus 2 alpha, sorry, not a 2 alpha square, it's just 1 alpha square. 1 alpha square. So alpha square plus alpha plus 1 equals 0. We have 2 beta cube plus beta square plus beta plus 1 equals 0. And again, you could do this directly if you have practice. 2 gamma cube plus gamma square plus gamma plus 1 equals 0. I'm doing this so that you realize how symmetric functions do work actually. So again, we had all these equations as usual. We get twice of alpha cube plus beta cube plus gamma cube plus alpha square plus beta square plus gamma square plus alpha plus beta plus gamma and plus 3. This equals 0. And then let us call this as sum k prime, 2k prime plus alpha square plus beta square plus gamma square can be written as alpha plus beta plus gamma the whole square minus twice of alpha beta plus beta gamma plus gamma alpha. And this is just alpha plus beta plus gamma plus 3. And this equals 0. And what is alpha plus beta plus gamma? From uh, here, again using Vieta's relations, it's negative 1 by 2. So we get a negative 1 by 2 the whole square minus twice of alpha beta plus beta gamma plus gamma alpha. What's that? That's going to be 1 by 2 again from Vieta's relations. We're going to get 1 by 2 plus alpha plus beta plus gamma. Just now we saw that it's negative 1 by 2. And then a plus 3. This should equals 0. So then we have 2k dash plus 1 by 4 minus 1 and minus 1 by 2 plus 3 equals 0. So we get 2k dash. What do we have? So this is 1 by 4 minus half would give you minus 1 by 4. Then plus 3 equals 0. So we get 2k dash minus 5 by 4 plus 3 equals 0. And we get that 2k dash is in fact 5 by 4 minus 3. That is going to be 5 minus 12 divided by 4. So that's going to be minus 7 by 4. So what's going to be k dash? It's going to be minus 7 by 8. Okay, so sort of a bit difficult kind of a value to accept, because you may tend to see that, oh, it might not give us the answer as 16 because there's a fraction, but you would see that it gets cancelled once we do it. So k dash is negative 7 by 8. And what was the expression simplified to? This expression minus 8 times minus 16 minus 8 times minus 16. Then what else was there? Plus 2 times minus 8 plus 2 times minus 8 times alpha cube plus beta cube plus gamma cube. And what's alpha cube plus beta cube plus gamma cube? It is going to be this. That is what we assumed as k prime. That's going to be negative 7 by 8. So what do we have? This minus and a minus becomes plus, and an 8 and an 8 gets cancelled. So what do we have? Minus 8 times minus 16 plus 2 times 7, that is plus 14. That's going to give you minus 8 times minus 2, and that's going to give you 16. And the value of the expression is 16. And what had they given us to show that? This expression evaluates to 16. And we did the same. We've got that expression to be equal to 16, and thus we are done with the problem. So this is the idea of symmetric functions in polynomial problems. So it's a very helpful tool. And for those of you who are interested, this problem is from a book known as Pathfinder for Olympiad Mathematics. And it's from chapter 1, Build Your Understanding 3 exercise. And I have practiced symmetric functions and polynomials from that book. And it's a really good book. And those of you who are interested to learn how to solve problems like these, practice more problems, you can always refer to this book. And yeah, that's it in this video. I hope you enjoyed the symmetric functions and how helpful it is to simplify polynomial problems like these to a great extent. Thank you for your patient hearing, and I'll come up with another video soon.